Hello, good morning students. Till now we have seen for the first chapter, that is distance, displacement, then speed, velocity, then uniform motion, non-uniform motion, etc. Also we have studied acceleration. Rate of change of velocity is acceleration. Positive acceleration, negative acceleration and zero acceleration we have studied. Today we have to plot the graph. You have studied in mathematics how to plot a graph. So distance time graph for uniform motion. The time is given in seconds and distance covered by a car in that particular time is given here. It is in meters. Now as you know very well, initial velocity time is 0. So initial velocity or initial distance covered is 0. Now the gap is of 10 seconds, 10, 20, 30, 40, 50, 60 and 70. In each 10 seconds means equal time interval is there. Yesterday we have studied. Now here also in each 10 seconds the car has covered distance 15 meters, 30 meters, the table of 15, 15, 30, 45, 60, 75, 90 and 105. By observing the readings, we can say that this is an example of uniform linear motion. This also can be asked in examination. You are given the table, you have to draw the graph and you have to tell whether this is the uniform motion or non-uniform motion. I have drawn the graph with the help of pen because it should be visible to you. But in the examination, you have to draw the graph with the help of pencil. Now, see on the x-axis. Now, you can see the same time interval is there. The difference is of 10 seconds. And here, the car has covered in each 10 seconds 15 meter distance. You have to plot the graph in this way. Time is taken on x-axis. Time is in seconds. Distance is taken on y-axis. Distance is taken in meters. Now you have to take the scale. You have studied this, how to draw the graph. I have taken on x-axis time, and in that time this much distance is 1 centimeter, and 1 centimeter is equal to 10 seconds, and distance 1 centimeter is equal to 20 meters. So in this way, now plot the graph. For 0 it is 0, then 10, 15, in that way. Take the points accordingly and plot the graph. Now join all these points. You observe that the distance time graph for uniform motion is a straight line graph. You have to draw the graph. You have to write the readings also. Or otherwise in the examination it may be asked, graph is given, table is given, you are asked to draw the graph and tell the nature of the graph, what type of motion it is. Now if it is not given in this way, so by observing the table you can understand this type of motion is called the uniform motion, or this is an example of uniform motion. The car has covered in each 10 seconds 15 meter distance. So this is a graph for uniform motion. Now we'll study the graph for non-uniform motion. Now these are the readings. Time again in seconds, distance covered by the car in meters. Now there is difference of 5 seconds. In each 5 seconds, what is the distance covered by the car is given: 7, 12, 20, 30, 41, 50 and 58. By observing the readings, you can understand the car has not covered equal distance in equal time intervals. In the previous example, we have seen in equal time intervals, the car has covered equal distance. So it's an example of uniform motion. Now from the table or from the readings, you can observe or you can see in each 5 seconds, time interval is same of 5 seconds, but the distance covered by the car is not same. Here 7 plus 5, 12, 12 plus 8, 20. The difference is different in each interval. And the nature of the graph, accordingly you have to plot the graph and observe the nature of the graph. So Again same way as in the first example. On the y-axis there is distance in meters, on x-axis there is time in seconds. The difference, that is with 20 centimeter, is equal to 5 seconds. 25, 10, 15, 20, 25, 30 and 35. And on the y-axis there is distance, that is 20 centimeter is equal to 10 meters. 10, 20, 30, 40, 50, 60. In that way, last reading hour is 58. So it is possible now to plot a graph. Now in that way, what is there for 0 to 0, 5 to 7, you have to plot accordingly the points and join those points. Here you observe that the nature of the graph is not a straight line graph. So always remember that by observing the table or readings, you can easily tell this is a type of non-uniform motion. Previous example is of uniform motion, and whenever there is uniform motion, the distance time graph is always a straight line graph, and whenever there is a non-uniform motion, the distance time graph is not a linear graph, or it is not a straight line graph. Here you have to draw the graph with the help of pencil and practice it. Now one more graph we have to study, that is velocity time graph for uniform velocity. Example is given in your book. A train is moving with a uniform velocity of 60 km per hour for 5 hours. Means the train is continuously moving with 60 km per hour. There is no change in velocity. So velocity is uniform velocity. So train is continuously moving for 5 hours with the speed of 60 km per hour. Means in 5 hours, how much distance it has covered? Orally you can calculate. How much distance? 60 multiplied by 5. 60 multiplied by 5, that will come to be, that you know very well, 300 kilometer total distance the train has covered in 5 hours with the continuous constant velocity of 60 km. Now this is the graph, and you are asked to calculate the distance covered by the train in between 2 and 4 hours. Means 2 and 4 hours means how much hours you can calculate. This is 2 to 3, 1 hour, and 3 to 4, 1 hour. It is total 2 hours. Means how much distance the train has covered in 2 hours? Orally also again you can calculate 60 multiplied by 2, 1 hour in plus 1 hour, and 60 km per hour. So 60 multiplied by 2 is equal to 120 kilometer distance the train has covered. Now, is there any similarity with the distance covered by this? Means in between 2 and 4 hours, and this figure you can understand A, B, C and D. This is a rectangle, and if you calculate the area of the rectangle, then you know the formula length into breadth, L into B. L is equal to C. L at 2 hours, L is equal to 60. 4. L is equal to, means this much distance is 60. For every hour it has covered how much distance? 60 km. Now this is 60, this distance 60, and this is 2, 1 and 2. 60 into 2, length into breadth of the rectangle. Area of rectangle is equal to L into B. L how much? L is 60, B is 2. 60 multiplied by 2 is equal to 120 km. And in this way, if any object or this train is moving with the constant velocity or uniform velocity, then the distance covered by the train in 2 hours is same to that of the area of rectangle. In this way you can calculate. Similarly here also, if suppose you take here from 0 means between 5 hours, you can draw one more rectangle and again calculate 60 multiplied by 5. So area of that rectangle is equal to 300 kilometer. Means in 5 hours the train has covered 300 kilometer distance. So this is similar to the area of the rectangle. Again, this is also similar to the area of this ABCD rectangle if the velocity time graph is for uniform velocity. So today we'll stop here and next we'll see tomorrow.